this video, we'll be taking a look at section 4.2, properties of isosceles triangles. So for our warm-up today, we're just going to take a peek at reviewing the vocabulary for an isosceles triangle. So the vertex angle is the angle formed by the two congruent sides. So in this case, it's angle T. The base angles are the two angles formed by one of the congruent sides and the third side. So that would be angle R and angle I. The congruent sides we call legs. So those are segments. That would be segment TR and segment TI. And then the base is the side that is not congruent. In this case, it would be segment RI. So we're going to take a look at some properties of isosceles triangles. First, I want you to draw segment AB of any length below. And we're going to label it AB. Doesn't matter what it is. So then from A and B, we're going to construct an isosceles triangle by copying a segment of equal length from each endpoint. So what I mean by that is go ahead and set your compass to any length. It does have to be over half the length of AB, which we'll get to in section 4.3, the reason why that's true. But after that, it can be any length. So it can't just be like a tiny little boop, boop, swoop. But other than that, almost anything is fair game. So go ahead and pick a length for your compass. Put your stylus on point A and swoop your compass above segment AB. Give yourself a pretty generous arc because you want to make sure that it touches the arc from point B. So then go ahead to point B, put your stylus here, and swing your arc. This is going to be your point C. And this is actually going to be your vertex angle because these two segments are congruent. Again, why? Because we didn't change our compass distance when we swooped from A and when we swooped from B. Therefore, those two segments are congruent, creating the isosceles triangle, and then that's why C is the vertex angle. So then A and B are the base angles. So then I want you to use your protractor to compare the measures of the base angles. So measure angle A with your protractor and measure angle B. Ignore the folding the paper part. What should happen, they should have the same measure, so they should be congruent. And if you, again, since we're watching a video and you're not in a group, go ahead and do another isosceles triangle. You can maybe make your base longer and maybe make your congruent side shorter and then go ahead and measure those base angles, and I think you will find, I know you will find they are congruent. So that's our conjecture. Oh, for some reason, we don't have a conjecture there. So basically, it means if a triangle is isosceles, then the base angles are congruent. So is the converse true? So this time, we don't know if the triangle is isosceles. So if the triangle is isosceles, then the base angles are congruent. But the converse would be if the base angles are congruent, then is the triangle isosceles? We don't know. Let's take a peek. I-S-O-S-C-E-L-E-S. Okay. So what we want to say here is, suppose a triangle has two congruent angles, must it be isosceles? So we're going to draw a segment AB. This is going to be our base. Okay? Then we are going to draw a segment and draw an acute angle at point A. So go ahead and just draw a segment off of that so that this angle here is acute. The reason why it can't be obtuse is because this is one of the base angles, and we just learned in section 4.1 that all the sum of the angles in the triangle has to be 180. So if we have an obtuse angle, it's over 90, and since the base angles are congruent, we just looked at that. If we have double that, we'll already be over 180. Or so again, think about if this is your base and these are your two base angles coming out, they're not going to make a triangle. So you're going to draw a segment so you have an acute angle. And then you're going to copy this angle over at the other vertex, assuring the base angles are congruent. So go ahead again. How do you copy an angle? Draw your swoop from, put your stylus on the vertex, swoop. Put your stylus on the vertex, copy that swoop. Put your pencil on one intersection point, put your stylus on the other. Open your compass to that length. Go ahead and put your stylus here and copy that. And then finally go ahead and connect. So we've created a triangle where the base angles are congruent, and then our goal is to see if our triangle is isosceles. And this, by the way, would be point C. Here's A and B. So then we are going to actually use our compass. We could use a ruler, but when you use your compass to compare the length, so what we're going to be looking at is we're going to be looking at the length of this segment and the length of this segment. So to do that, take your compass and put your stylus on A and open it up so your pencil's touching C and just kind of swoop that. Just kind of get that distance, open up your compass, and then go ahead and put your stylus on B, and if you look, your compass setting should totally touch point C without you having to move the compass. We can use patty paper to, so what did we notice? They're congruent. How can we use patty paper to confirm that? Well, we could just lay the patty paper over the segment, trace it, and then compare it to the other side. So then the converse of the isosceles triangle conjecture is if a triangle has two congruent angles, then the triangle is isosceles. Please ignore my dog in the background going a little bit bananas. Okay, so what other triangles does this conjecture apply to? It actually applies to equilateral triangles. And again, why? Because technically an equilateral triangle is isosceles, right? Isosceles actually has at least two congruent angles. Usually we think of it, at least two congruent sides. Usually we think of it having only two congruent sides, but it doesn't technically have to have just two. Okay, so now we're going to find some missing angle measures. We're going to remember, combine this with the other conjectures we've learned. So triangle sum means we have 180 degrees in a triangle. And then what did we just learn? We just learned that the base angles are congruent. That's the conjecture we just learned. So let's look at this one. You can pause the video and then try to do these on your own, or you can just follow along with me right now. So here we have an isosceles triangle because I have two segments marked, and here we have angle T at 22 degrees. Angle 22 degrees is the vertex angle, right? So now if we go to find the measure of angle H, I'm just going to give it a variable X. H is also congruent to O. So if I want, I could write an equation, 2X plus 22 is 180. Or I could solve that equation by subtracting 22 and dividing by 2, or I could just do some arithmetic by taking 180 minus 22 and then dividing that answer by 2. It doesn't matter how technical you want to get. Sometimes I like writing an equation just to remind myself I can. So that would be 158 for H and O, but remember they are congruent. And I'm just doing this by hand, but you can certainly use a calculator. And so the measure of angle H is 79 degrees. Let's look at example 2. We know that the perimeter of triangle MTB is 605 inches. And so the first thing it asks us to find the length of MV. So again, if the perimeter is 605, if I take 605 and I subtract 285 and 160, I'm just going to add that real quick. 445, if I subtract that, turns out this is 160. Now, why is that important? Because now we have an isosceles triangle. This side is congruent to this side. And then that means that angle V and angle T are congruent because the base angles are congruent. So if this angle is labeled X, then this angle is labeled X. So then to find the measure of angle M, what I'm going to do this time is definitely write an equation. So X, well 2X plus x plus 99, 2x because this is x and this is x, and they're congruent, equals 180. So 3x plus 99 is 180. Subtract 99 from both sides gives us 3x is 81. And then dividing by 3 gives us x is 27 degrees. So x is 27, right? But then it asks us for the measure of angle M, so we have to go ahead and substitute x in. So 99 plus 27 is 126 degrees, and this is 160 inches. I want to make sure I have a proper label on that. So those were 2 example problems using our new conjectures. Take a look at the homework and review the notes if needed.